Welcome dear students. We discussed about AC bridges in the last video. So we have studied Maxwell's bridge, Maxwell inductance bridge and Maxwell inductance capacitance bridge. Both are used for measuring unknown inductance. Next we can study other two types of bridge, SCHERING bridge and WEINS bridge. SCHERING bridge is used for measuring unknown capacitance and WEINS bridge is used for measuring unknown frequency. So first we can see SCHERING bridge. So SCHERING bridge for measuring unknown capacitance. This is the previous university question asked. Using SCHERING bridge, show how capacitance and dissipation factor of unknown capacitor is measured. So this is the bridge circuit. As usual, there will be 4 branches. And in this case, branch AB, which is V1. So this comprises the Z1. Impedance Z1 is R1 and C1 in series. So what is the impedance? Z1 equal to R1 plus 1 by j omega C1. And Z2, that is AC branch, consists of only capacitance. So 1 by j omega C2. Z3 is consists of only resistance. So Z3 is R3. Z4 having parallel combination of resistance and capacitance. So R4 into 1 by j omega C4 plus R4 plus 1 by j omega C4. So multiply this equation, you will be getting R4 by 1 plus j omega C4. These are the impedance in 4 branches. So we know that when bridge is said to be balanced, this detector shows zero deflection. When will this detector show zero deflection? When the potential between B and C equal. Potential at B and potential at C equal means there is no current flow, no potential difference, so no current flow. So whatever current flowing through AB branch will flow through BD, that is I1. Same current I1 will be flowing through AB and BD. Similarly, same current I2 flow through AC and CD. And potential at B and C equal means V1 equal to V2 and V3 equal to V4. So using that condition, we can balance the bridge. We know that the product of opposite branches of impedances are equal. That is Z1, Z4 equal to Z2, Z3. So what is Z1? Z1 is R1 plus 1 by j omega C1. Z4 is R4 by 1 plus j omega C4 R4. Z3 is R3 and Z2 is 1 by j omega C2. Multiply this equation. Cross multiply this denominator. So R4 into R1 plus 1 by j omega C1 equal to R3 by j omega C2 into 1 plus j omega C4 R4. It is R4 R1 minus j by omega C1 into R4 equal to, multiply these two terms, you will be getting this equation. Equate the real part. R4 R1 equal to R2 R3 R4 C4 by C2. So from this you can calculate R1. From this equation, second equation, you can calculate C1. So you got the unknown capacitance and internal resistance of that branch. Next, dissipation factor. Dissipation factor is given by tangent of delta, that is angle between C1 and R1. So that is given by omega C1 R1. That is omega into, substitute C1 value and R1 value, you will be getting omega R4 C4. So this is the method of measuring unknown capacitance and dissipation factor using SCHERING bridge. Next we can see how to measure the unknown frequency using WEINS bridge. As usual, there will be 4 branches. So where Z1 is R1 parallel C1, R1 by 1 plus j omega C1, Z4 is R4, Z3 is R3, Z2 is R2 plus 1 by j omega C2. So taking j in the numerator minus j by omega C2. Then balance condition Z1, Z4 equal to Z2, Z3. So that we can again write as Z1 by Z3 equal to Z2 by Z4. So substitute this value. Z1 is R1 by 1 plus j omega C1 R1, Z3 R3, Z2 R2 minus j by omega C2, Z4 R4. Next cross multiply this equation. R1 R4 by 1 plus j omega C1 R1 equal to R3 by R3 into R2 minus j by omega C2. Then take the LCM, you will be getting this equation. Next cross multiply again these two equations. You can do it in your note, then it will be more cleared. So omega C2 R1 R4 equal to this term, cross multiply this term, you will be getting 4 components. So next is taking the omega outside from the real part. Omega into C2 R1 R4 equal to, this is one real part, here also second real part. So you'll be getting this equation. From this equate the real part, you'll be getting C2 R1 R4 equal to C2 R2 R3 plus C1 R1 R3 minus J. Write the imaginary part here. Next, what you have to do, divide the above equation by C2 R1 R3. Divide the above equation C2 R1 R3. This is your equation. Divide by C2 R1 R3. So C2 R1 get cancelled, remaining R4 by R3. Next C2 R2 R3 by C2 R1 R3 being R2 by R1. Next this equation C1 R1 R3 by C2 R1 R3. So C1 by C2. So you'll be getting R4 by R3 equal to R2 by R1 plus C1 by C2. That is the equation you got here. Next equate the imaginary part, omega square C1 C2 R1 R2 R3 minus R3 equal to 0. So equate these two parts, you'll be getting omega as 1 by root C1 C2 R1 R2. Frequency is omega is 2 pi f. So f is 1 by 2 pi root of this equation. And in most of the bridges R1 R2 and C1 C2 are same. So you'll be getting 1 by 2 pi RC. So this is the equation for WEINS bridge for finding the unknown frequency.